Good day, everyone. I am Lea Pefanio with my co-members. In this video discussion, we talk about the programming languages, Lesson 3, Part 1, which is the types of data types. So let's start. A data type defines a collection of data objects and a set of predefined operations on those objects. Computer programs produce results by manipulating data. ALGO stands for Algorithmic Language. 68 provided a few basic types and a few flexible structure defining operators that allow programmer to design a data structure for each need. Actually, the ALGO is a language that is very stable because it is a family of portable programming languages for scientific computation that have the strong influence on the other languages. So, a data type have a descriptor. So, it collects the attributes of a variable. In an implementation, a descriptor is a collection of memory cells that store variable attributes. If the attributes are statistic, that means it contains the same value for each object. The descriptor are required only at a compile time. So they built by the compiler usually as a part of the symbol table and are used during the compilation. For dynamic attributes, it is part or all of the descriptor must be maintained during the execution. Descriptors are used for type checking and by allocation and deallocation operators. We should remember that a data type is an attribute of a variable, which tells us the compiler or interpreter how the programmer intends to use the variable. And it defines the operation that can be done on the data and what type of values can be stored. So it has the different data types, which are the primitive data types, the character string types, user-defined ordinal types, array types, associative arrays, record types, union types, pointer, and the reference types. So the first one is the primitive data types. Those not defined in terms of other data types are called primitive data types. The primitive data types of a language, along with one or more type of constructors, provide the structured types. Actually, almost all of the programming languages such as the C++, the C, the JavaScript, and etc. that provide a set of the primitive data types. Some of the primitive data types are merely reflections of the hardware. For example, most integer types. So, the primitive data types are the most basic data types, which is available within the Java language. These types serves as the building blocks of data manipulation in Java. Such types serves only one purpose, containing the fewer simple values of a kind. It have a different primitive data types, which are the numeric types, Boolean types, and character types. So the first one is the numeric types, which means it involving numbers. So every data type has a range of values. The compiler allocates memory space for each variable or constant according to its data type. The numerical types, which are the integer, floating point, and decimal. Integer. Almost always an exact reflection of the hardware, so the mapping is trivial. There may be as many as 8 different integer types in a language, such as byte, Boolean, char, double, float, int, long, and short. In Java, it only has 4: the byte, the short, int, and long. Integer types are supported by the hardware, and we must remember that integer data type contains any whole number and can be positive, negative, or 0. The example: 0, 2, 33, and negative 199. In integer data type, it does not have any fractional part. The second one is the floating point. Model real numbers, but only as approximations for most real numbers. On most computers, floating point numbers are stored in binary, which exacerbates the problem. Another problem is the loss of accuracy through arithmetic operations. Languages for scientific use support at least 2 floating point types, sometimes more: the float and double. The double type is twice as big as a float, so the double is known as the double precision, and float as a single precision. Normally, you should use the double type because it is more accurate than the float type. The collection of values that can be represented by a floating type is defined in terms of precision and range. Precision is the accuracy of the fractional part of a value, measured as a number of bits. The figure below shows a single and double precision. Range is the range of fractions and exponents. To understand this, we must first understand the structure of float and double in memory. This figure, the range of the memory structure that float and double is determined by the number of digits of the index. The exponent of float has 8 digits, while the exponent of double has 11 digits. In float, as you can see in the little box is a 1 bit, which is a sign of bit. The 8 bits are the exponent bit. So the 23 bits is the fraction, or it also called mantissa bit. So the second one is the double. As you can see, the little box is a 1 bit, then it is called the sign bit. It has 11 bits, which is the exponent bit. Then the 52 bits is called a mantissa bit, or the fraction. Precision of float and double is determined by the number of the digits in the mantissa, or the fraction. Floating point numbers are stored in memory according to the scientific notation. So the last one is the decimal. Most larger computers that are designed to support business applications have hardware support for decimal data types. Decimal types store a fixed number of decimal digits with decimal point at a fixed position in the value. So these are the primary data types for business data processing and are therefore essentially tuple. Actually, the tuple stands for Common Businesses-Oriented Language. It was designed for business computer programs in industries such as finance and human resources. The decimal has an advantage: the accuracy of decimal values. The disadvantages: it is limited range, since no exponents are allowed, and its representation wastes memory. The decimal data type is an exact numeric data type. defined by its precision. Precision is also called the total number of digits, and scale, which is the number of digits to the right of the decimal point. For example, as you look in this figure, the precision is equals 10 because it is the total number of digits in this figure. And the scale is equals to 5 because it is the number of digits to the right of the decimal point, which is the 67890. 67890. We must remember that the decimal data type is suitable for storing accuracy data, where required a range of values or numbers of digits to the right of the decimal points exceeds the capabilities of the money data type. For display purposes, accuracy sign cannot be specified for decimal values. Specify the decimal data type using the following syntax: decimal, open parentheses P and S, and close parentheses. The P defines the precision, which is it is minimum to 1 and it is maximum to 39. The S defines the scale. So the scale of a decimal value cannot be exceed its precision. Scale can be 0, no digits to the right of the decimal point. So the following defines types with precision of 23 decimal digits, 5 of which are after the decimal point. Decimal, open parentheses 23, and 5 close parentheses. The second type of primitive data types are the Boolean types, introduced by Algol 60, which means that stands for algorithm language. They are used to represent switch and flags in programs. The use of booleans enhances readability. One popular exception is C89, in which numeric expressions are used as conditional. In such expression, all operands with non-zero values are considered true, and 0 is considered false. Actually, in Boolean data type, it comprises of a bit of information and can be stored only true or false values. So this data type is used to track the true or false conditions. As you can see in this figure, it is an example of true and false conditions. That was all about the Boolean data type. And now, let's move further and understand the next data type, the character data type. The character data types. Char types are stored as numeric codings, ASCII or the Unicode. Traditionally, the most commonly used coding was the 8-bit code ASCII. ASCII stands for American Standard Code for Information Interchange. Actually, the ASCII is very important because it is the character encoding standard for electronic communication, and it is a codes that represent the text in the computers and or other devices. So the standard ASCII code only had a range of 0 to 128 characters, which is very limited in the range of characters. It basically only supports the English character set. A 16-bit character set named Unicode has developed as an alternative, but it has the range that is between 0 to 65,536. Java was the first widely used language to use the Unicode character set. Since then, it has found its way into JavaScript and C#. We must remember that in ASCII's characters, it have upper and lowercase alphabetic characters that are accepted literally. And there are two fixed length character data types, the char and C. Also, it has two variable length character data types, the varchar and text. That was all about the primitive data types. Now, let's move further and understand the next data types, the character string types.
Good day everyone, I'm Roselyn Salise. I'm here to discuss the character string types. So, a character string type is one in which values are sequences of characters. Important design issues. First, it is a primitive type or just a special kind of array. Second is the length of objects static or dynamic. C and C++ use char arrays to store char strings and provide a collection of string operations through a standard library whose header is string.h. How is the length of the char string decided? The null char, which is represented with 0. For example, char asterisk string is equals to apple. Char pointer points at the string apples 0. In this example, string is a char pointer set to point at the string of characters apples 0, where 0 is the null char. String typically operations: assignment, comparison, equal to or greater than, or etc. Catenation, substrings reference, pattern matching. Some of the most commonly used library functions for character string in C++ are string copy, copy strings, string concatenates on given string onto another, string comparison, lexicographically compares the order of their codes to strings. String length returns the number of characters, not counting the null. In Java, strings are supported as primitive type by string class. String length options. First is static length string. The length can be static and set when the string is created. This is the choice for the immutable objects of Java string class, as well as similar classes in the C++ standard class library, and the net class library is available to C number. Next is limited dynamic length strings. Allow strings to have varying length up to a declared and fixed maximum set by the variable's definition, as exemplified by the strings in C++. Next is dynamic length strings. Allow strings various length with no maximum. Requires the overhead of the dynamic storage allocation and deallocation but provides flexibility. Example, Perl and JavaScript. Evaluation aids readability. As a primitive type with static length, they are inexpensive to provide. Why not have them? Dynamic length is nice, but it is worth the expense. Implementation of character string types. Static length. Compile time descriptor has 3 fields. First is name of the type. Second is type length. Third is address of the char. In the table, there are 3. First is static string. Second, length and address. Compiler time descriptor for static strings. Limited dynamic length strings. May need a runtime descriptor for length to store both the fixed maximum length and the current length, but not in C and C++ because the end of a string is marked with a null character. As you can see in the table, limited dynamic string, maximum length, current length, and address. Runtime descriptor for limited dynamic strings. Dynamic length strings need runtime descriptor because only current length needs to be stored. Allocation and deallocation is the biggest implementation problem. Storage to which it is bound must grow and shrink dynamically. And there are two approaches to supporting allocation and deallocation. First, the strings can be stored in a linked list. Complexity of string operations, pointer chasing. And second is store strings and adjacent cells. What about when a string grows? Find the new area of memory and the old part is moved into this area. Allocation and deallocation is slower, but using adjacent cells result in faster string operations and requires less storage.
Good day everyone, I'm General Olaguir and I will be the one to discuss the user-defined ordinal types. User-defined ordinal types. An ordinal type is one in which the range of possible values can be easily associated with a set of positive integers. Examples of primitive ordinal types in Java: integer, char, and Boolean. In some languages, users can define two kinds of ordinal types: enumeration and subrange. In enumeration types, all possible values, which are named constants, are provided in the definition. C++ example. Enum colors, open curly brace, red, blue, green, yellow, black, close curly brace, semicolon. Colors, my color equals blue, your color equals red, semicolon, my color increment, semicolon. The enumeration constants are typically implicitly assigned the integer values 0, 1, and so on, but can be explicitly assigned any integer literal. Java does not include an enumeration type, presumably because they can be represented as data classes. For example, class colors, open curly brace, public final int red equals 0, semicolon, public final int blue equals 1, semicolon, close curly braces. Subrange types. An ordered contiguous subsequence of an ordinal type. Example, 12 to 18 is a subrange of integer type. Ada's design. Type days is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Subtype weekdays is days, range Monday to Friday. Subtype index is integer range 1 up to 100. Day 1, days, day 2, weekday, day 2 equals day 1.
Array types. An array is an aggregate of homogeneous data elements in which an individual element is identified by its position in the aggregate relative to the first element. A reference to an array element in a program often includes one or more non-constant subscripts. Such references require a runtime calculation to determine the memory location being referenced. Some design issues are as follows. First, what types are legal for subscripts? Second, are subscripting expressions in element references range checked? Third, when are subscript ranges bound? And so on. Arrays and indexes. Indexing is a mapping from indices to elements. The mapping can be shown as map, open parenthesis array, underscore name, comma, index, underscore value, underscore list, close parenthesis, right forward arrow, an element. Example, Ada assignment statement, sum, colon, equals to sum, plus, capital B, open parenthesis, capital I, close parenthesis, semicolon. Because open and close parentheses are used for both subprogram parameters, and array subscripts in ADA. This results in reduced readability. C-based languages use open and close brackets to delimit array indices. Two distinct types are involved in an array type: the element type and the type of subscripts. The type of subscript is often a subrange of integers. ADA allows other types as subscripts, such as Boolean, char, and enumeration. Among contemporary languages, C, C++, Perl, and Fortran don't specify range checking of subscripts, but Java and C# do. Subscript bindings and array categories. The binding of subscript type to an array variable is usually static, but the subscript value ranges are sometimes dynamically bound. In C-based languages, the lower bound of all index ranges is fixed at 0. Fortran 95, it defaults to 1. There are 5 categories of arrays based on the binding to subscript ranges. The binding to storage and room where the storage is allocated. 1. A static array is one in which the subscript ranges are statically bound and storage allocation is static, done before runtime. Advantages: efficiency, no allocation and deallocation. Example: arrays declared in C and C++ function that includes the static modifier are static. 2. A fixed stack dynamic array is one in which the subscript ranges are statically bound, but the allocation is done at elaboration time during execution. Advantages: space efficiency. A large array in one subprogram can use the same space as a large array in different subprograms. Example: arrays declared in C and C++ function without the static modifier are fixed stack dynamic arrays. 3. A stack dynamic array is one in which the subscript ranges are dynamically bound and the storage allocation is dynamic during execution. Once bound, they remain fixed during the lifetime of the variable. Advantages: flexibility. The size of the array is not known until the array is about to be used. Example is shown below. The user inputs the number of desired elements for array list. The elements are then dynamically allocated when execution reaches the declare block. When execution reaches the end of the block, the array is deallocated. 4. A fixed heap dynamic array is one in which the subscript ranges are dynamically bound and the storage allocation is dynamic, but they are both fixed after storage is allocated. The bindings are done when the user program requests them, rather than at elaboration time, and the storage is allocated on the heap rather than the stack. Example: C and C++ also provide fixed heap dynamic arrays. The function malloc and free are used in C. The operations new and delete are used in C++. In Java, all arrays are fixed heap dynamic arrays. Once created, they keep the same subscript ranges and storage. 5. A heap dynamic array is one in which the subscript ranges are dynamically bound and the storage allocation is dynamic and can change any number of times during the array's lifetime. Advantages: flexibility.
Arrays can grow and shrink during program execution as the need for space changes. Example, C# provides heap dynamic arrays using an array class ArrayList. ArrayList int list equals to new ArrayList open and close parentheses semicolon. Elements are added to this object with the add method, as in int array period add open parentheses next one close parentheses semicolon. Perl and JavaScript also support heap dynamic arrays. For example, in Perl, we could create an array of 5 numbers with @list equals to open parentheses 1, 2, 4, 7, 10 close parentheses semicolon. Later, the array could be lightened with the push function, as in push open parentheses @list 13, 17 close parentheses semicolon. Now the array's value is open parentheses 1, 2, 4, 7, 10, 13, 17 close parentheses period. Array initialization. Some languages allow initialization at the time of storage allocation. Usually, just a list of values that are put in the array in the order in which the array elements are stored in memory. Fortran uses the data statement or put the values in single line comment section on the declaration. Example can be shown below. C and C++ put the values in braces. Let the compiler count them. Int stuff open and close brackets equals to open curly brace 2, 4, 6, 8 close curly brace semicolon. The compiler sets the length of the array. What if the programmer mistakenly left a value out of the list? Character strings in C and C++ are implemented as arrays of char. Char name open and close brackets equals to Freddy. How many elements in array name? The array will have 8 elements because the null character is implicitly included by the compiler. In Java, the syntax to define and initialize an array of references to string objects. String, open and close brackets, names equals to open brackets, quotation, Bob quotation, comma, quotation, Jake quotation, comma, quotation, Debbie quotation. Other positions for the values can be specified and can be shown below. Implementation of arrays. Access function maps subscript expressions to an address in the array. Access function for single dimension arrays can be shown below. Accessing multi-dimensioned arrays, 2 common ways. Row major order by rows, used in most languages. Column major order by columns, used in Fortran. For example, if the matrix had the values 3, 4, 7, 6, 2, 5, 1, 3, 8, it would be stored in row major order as 3, 4, 7, 6, 2, 5, 1, 3, 8. If the example matrix above were stored in column major, it would have the following order in memory: 3, 6, 1, 4, 2, 3, 7, 5, 8. In all cases, sequential access to matrix elements will be faster if they are accessed in the order in which they are stored, because that will minimize the paging. Paging is the movement of blocks of information between disk and main memory. The objective of paging is to keep the frequently needed parts of the program in memory and the rest on disk. Locating an element in a multi-dimensional array, row major, location, open parenthesis, small letter A, open brackets, small letter I, comma, small letter J, close brackets, close parenthesis, equals address of A, open brackets, 1, 1, close brackets, plus, open parenthesis, small letter I, minus 1, close parenthesis, times, n plus, open parenthesis, small letter J, minus 1, close parenthesis, times, element underscore size. In this figure, we assume that subscript lower bounds are all 0. This figure also shows the location of the I and j element in a matrix.
The associative array is an ordered collection of data elements that are indexed by an equal number of values called k, used to store k-value pairs, used to represent collections of data that can be retrieved by specifying a name. For example, as you can see, this is an example of an associative arrays where you can see the phone number and its owner. So the phone number here represents the k. The k simply returns the k of the array element that currently being pointed to by the interval pointer. The k also used to find indices with names provided to them. So the k is the name that assigned to every arrays. Every k can only appear once in a directory and every k can only have one value. So sa isa ka k, isa ra pod ka value. In this example, sa isa ka phone number, isa ra pod ang tag-iya na nga number. Dili siya pwede mahimong duha or mahimong tulo kay pwede siya mahimo og error. So isa-isa ra gyud siya, isa ka k, isa ka value. And in this example, the value is the name or the owner of the phone number. How to find k in an array? Find the k in an array, use the function. Automatically, makita na nimo ang k nga imo gigamit. Let's continue the discussion with another reporter.
Record types. A record is possibly heterogeneous aggregate of data elements in which the individual elements are identified by names. So in C, C++, and C#, records are supported with a struct data type. In C++, structures are minor variation on classes. And COBOL means Common Business-Oriented Language, uses level numbers to show nested records. Others use recursive definition. This is the uses level number to show nested record. Others use recursive definition. Definition of record in ADA. Record structure are indicated in orthogonal way. Reference to record. Most languages use that notation. Example, does record period name. Then fully qualified reference must include all record names. Elliptical reference allowed leaving out the record names as long as the reference is unambiguous, for example in Kubul. First, comma, first of M dash name, comma, and first of M dash record are elliptical reference to the employee's name's first name. Operation on the record. Assignment is very common if the types are identical. ADA allows record comparison. Other records can be initialized with aggregate literal. Then Kubul provides moves correspondence. Copy a field of the source record to the corresponding field in the target record.
Onion types. A onion is a type whose variables are allowed to store different type values at different times during execution. Discriminated versus free onions. Fortran. C and C++ provide onion constructs in which there is no language support for type checking. The onion in these languages is called free onion. Type checking of onions require that each onion include a type indicator called a discriminated onion, supported by ADA. ADA onion types. Type shape is circle, triangle, and rectangle. Type colors is red, green, and blue. Type figure. Form shape is record. Field, Boolean. Color, colors. Case form is when circle is equal to or greater than diameter. Float, when triangle is equal to or greater than. Left side, right side. Integer. Angle. Float, when triangle is equal to or greater than. Side 1, side 2. Integer. In case. Semicolon. End record, semicolon. Rectangle, side 1, side 2. Circle, diameter. Triangle, left side, right side, angle. Discriminant, form. Color, field. ADA onion type illustrated, a discriminated onion of three shape variables. Evaluations of onion. Potentially unsafe construct. Java and C number do not support onions. Reflective to growing concerns for safety in programming language.
Pointers. A pointer types in which the bars have a range of value that consists of memory, addressing, and special value. Nil. The value nil is not a valid address and is used to indicate that a pointer cannot currently used to reference any memory set. Pointer operation. Pointer types usually include two fundamental pointer operation, assignment, and dereferencing. Assignment set a pointer's bars value to some useful address. Referencing takes a reference through one level and direction. In C++, dereferencing is specified with asterisk as a prefix unary operation. So each VTR is a pointer bars with a value of 7080 and cell whose address is 7080 has a value 206. Then the assignment pointers problem. Juggling pointers, that means dangerous, and loose heap dynamite variables is wasteful. Then pointers in ADA. Some juggling pointers are disallowed because dynamite object can be automatically delocated at the end of pointers type scope. The loose heap dynamite variables problem is not eliminated by ADA. Pointers in Fortran 95. Extremely flexible but must be used with care. Pointers can be pointed at any variable regardless of when it was allocated. Pointers arithmetic is possible in C and C++, makes their pointers more interested than those of the other programming language. Then, unlike the pointers of Ada, which can only point into the heap, C and C++, pointers can only point or virtually any variables anywhere in memory. Explicit differencing and address of operators. Then, in C and C++, the asterisk denotes the differencing operator and ampersand denotes the operator for producing the address of a variable.
Reference types. C++ includes a special kind of pointer type called a reference type that is used primarily for formal parameters in function definition. A C++ reference type variable is a constant pointer that is always implicitly dereferenced. Because a C++ reference type variable is a constant, it must be initialized with the address of some variable in its definition. And after initialization, a reference type variable can never be set to reference any other variable. Reference type variables are specified in definitions by preceding their names with ampersands. For example, int result equals 0 semicolon, int ampersand ref result equals result semicolon, ref result equals 100 semicolon. This code segment result and ref result are aliases.
In Java, reference variables are extended from their C++ form to one that allow them to replace pointers entirely. The fundamental difference between C++ pointers and Java references is that C++ pointers refer to memory addresses, whereas Java references refer to class instances. Because Java class instances are implicitly deallocated, there is no explicit deallocation operator. There cannot be dangling reference. C# includes both the references of Java and the pointers of C++. However, the use of pointers is strongly discouraged. In fact, any method that uses pointers must include the unsafe modifier. Pointers can point at any variable regardless of when it was allocated.